now just a blank map in ArcGIS Pro. And what I want to do is bring in from my Module 2 data, the geodatabase M2 data, and the feature dataset data, the feature class called points1, which is a series of discrete points. And I might just change the color of those so that they're a little bit easier to see. I'll make them black, I think. There we go. So the purpose of converting these discrete features into a raster is to ensure that each feature will have at most one raster cell in the output raster. So that right now, for example, if I open up the attribute table for the points, and I can see that I have 0 of 100 selected. And that tells me we have 100 points here. So we want to represent 100 discrete points as a raster with at least 100 cells that have different identifiers. So to do so, I'm going to go over to my Analysis, Tools, and then I'm going to go to Toolboxes, and then we have Conversion Tools, and in Conversion Tools, we have to raster. And I'm just going to go to Feature to Raster or Point to Raster. Point to Raster just has more details and controls on how points are converted to raster. And it always takes a bit of time to open the first geoprocessing tool. So my input features are going to be points1, so I'm just going to drag them over and drop them there. The value field, I'll use object ID. That's a unique identifier for each point. And then the output raster data set is point to raster, points1, point to raster, and I could choose to save that, for example, into my geodatabase, which would be, in this case, the default geodatabase. You can choose elsewhere. Cell assignment, most frequent is fine. Since we want one cell per point, it doesn't really matter what you put there. We don't have a priority field that could be used for ranking the different points in any way. And then we have a default cell size here, 7.6. So we'll just run it and see what happens. So I'm going to run that now. And here, it will run fairly quickly. And so now I have, in my table of contents, on the left-hand side, I have points and then points as raster. Now the raster points are 7.6 meters each, so they're hard to see. I have to zoom in to see those actual raster cells that belong to these points. My next thing that I need to check then is that I have to open up the attribute table for the point raster layer and see if there are at least 100 different points in there. And there are 100. So that means that the default resolution that was chosen by ArcGIS here for this point data set, the cells were appropriately sized to produce one cell for each input point. And so that means we could represent all of the points at that cell size. But it's an odd cell size, isn't it? What if we had done the same thing and instead changed the cell size to, let's say, 15? So if I chose 15 as a cell size and I click Run, will we still have 1 point per output cell? Or will sometimes we have 2 points falling in the same output cell. So at 15, I'm now going to open up my attribute table again for the point raster layer, and I still have 100. So 15 is also a viable cell size here, because our number of points in equals number of cells out. So how about if I went up to 30? I'll just run that, because we want to use the maximum cell size possible to achieve discrete object representation, because that means we have less memory requirements to store that raster, and operations with that raster will be much quicker. So at a 30 meter by 30 meter cell size, let's have a look here. Do we still have 100 points or cells coming out? 99 now. So now we've done something we shouldn't have. At a cell size of 30 meters, that is too large of a cell size to ensure discrete object representation in our output raster. Because at some point in here, there were 2 points in a single cell. Let's see if we can see where those are by just moving around a bit here. It's hard to see with the naked eye where those extra points were, and it's still just redrawing here. But somewhere 2 points fell in the same cell, and so those 2 points became a count of 1 cell in the output, which is not appropriate, and that wouldn't be good for discrete object representation. So how can we more formally figure out what cell size we need? Here we took a default and it happened to work. But we may not want to have to check every time that our default works, although it's a good thing to do. That's called validation of a GIS process. And you should always think about, well, how can I ensure that what I expected to happen actually happened, that my result is good and not incorrect? So if we wanted to convert a bunch of different layers, well, what we need to do is find the minimum nearest neighbor distance among the points that we see here. So just the points. So we find the 2 points that are closest together. And to do that, we can use the near. So what I want to do then is find for every point how far it is to the closest next point in this pattern. That's called the nearest neighbor distance. And to do that, I can use the near tool. So I'll go to my geoprocessing pane, and then in the Find Tools dialog, I'm just going to type near. And it comes up Near Analysis Tools. So I'm going to click on that to open up the Near tool. My input features will be the points, because I want to find how far each point is from the next closest point. And then points 1 also becomes the near features. I won't touch anything else here. I can leave all those as their default parameters. And now I'll click Run. And this will add a near dist field to the points 1 layer that contains the nearest neighbor distances. So let's have a look at that now that it's finished. I go over to the points 1 layer and I open the attribute table. And here we see, for example, if I look at this point, and I'm just going to say zoom to, so that point has 0.71. So I'm looking in the near FID field. So the ID of that point is 1, the object ID, and the nearest other point has ID 71, and it's 110.59 meters away. So if I go back down here, and I'm just going to scroll down, and I'm going to click on 71 with my control button, now I see that it's these two here that have been selected. So point 1 and point 71 are each other's nearest neighbors, and it so happens they're 110 meters apart. Now, going back up to the top of the table, what I'm interested in here is how far apart the two closest points are. So I go to my near dist field, like so, and I click on it. And I want to probably go up to map in the top, clear to make sure I don't have anything selected while I do that. And then I want to go back up to the top again, like so, to sort these. So if I sort that way or sort that way, I have to right click and say sort ascending. And there it is, 8.56. So 8.56 meters is how far apart the two closest points are in this pattern. So I'm just going to zoom to that. And if I select those, you'll see that 55 is next to 70, and 70 is next to 55, like so. So these 2 points now are the two closest points. So to ensure that I choose a raster resolution that is going to be sufficient to ensure that no matter where the raster origin is in space, that there is no way that one cell could ever possibly encompass both of these features, would be to choose a resolution which is 1/3 of that particular value. So 8.56 meters, I can simply divide that by 3. And we can do that on a calculator, right? We can say, okay, open a calculator. And now with this calculator, we can say 8.56 divided by 3. And that's 2.85 meters. So I would round that up to 2.8, just leave it at actually 2.85. That should be sufficient. So if I go back then and I want to reconvert my points using that new knowledge of 2.85 meters as a cell size that will ensure that no 2 points can ever fall within the same cell, I go back to my conversion tools, point to raster, and again I can bring in points 1 as the input points, and down here for cell size, 2.81, or 2.85 is what we said, 2.85. Now, when I click run, that will create, again, an output raster where I will know that there will be 100 cells output for the 100 input features. And I don't have to check at that point because I've calculated a sufficient cell size to ensure that outcome. But just for fun and for good best practices, we check anyway. We just open the attribute table for the new cells, and we see that we have, okay, only 2 were converted because I had selected 2 of them by an accident. So I'd have to go back to clear, rerun the tool, and then it will do the raster conversion for everything. So it's a good thing I did check because previously I had just selected 2 features, 2 of the points, and because of that, the toolbox tool in the geoprocessing window or pane only operated on what was selected. That's the way ArcGIS Pro works. And it's easy to forget that you've selected something. And you're wondering, why don't I see anything coming out the other end of my tool? It looks blank. Well, it's probably because you just selected something somewhere and forgot about it. So it's always a good idea to go up here and clear all selections before you run a tool, unless, of course, that's how the behavior that you actually want. So it can be advantageous in some cases. So now we're back to this point to raster. Let's open her up again. And we see we have 100 cells for 100 input points.